So in this video, we're going to talk about some new information around polynomial functions and their models. So first things first, what is a polynomial function? So essentially, in layman's terms, it's a sum of monomials, but it is defined by this long equation here that has multiple parts. So this a base n is called our leading coefficient, so that's some number that leads the polynomial function. And then this whole thing is the dominating term. And this thing at the end is a constant, so that's usually just a number because the n, or the degree of your x, is 0, which anything to the 0 power makes it 1, hence why that's just a constant term. And if I plug in 0 here, that is going to be our y-intercept because everything else will be 0. And just another thing is that n is our degree, which tells us the degree of the polynomial. All right, something else to know is that a polynomial has multiple terms. You've seen these before. And these two are not polynomials. So if there is a fraction involved, and including this negative exponent, which will turn into a fraction, those are not polynomials. All right, another thing to know is a power function. So that is defined by this function right here, where f of x equals a, where that's some coefficient, and x to the degree n. So if we look at our examples here, these are three very basic power functions. They're kind of like parent functions, where they are a monomial, but they can have a leading coefficient that's not 1. Something else to know about a polynomial function is that it's going to have zeros or roots, much like the quadratic functions we've studied. So something to know is that a real zero is any real number, r, for where I plug in this number here for x, gives me y equals 0. So it's like solving for the roots of a quadratic equation, except you may have more than 2 roots for a polynomial, depending on the degree. So something else to know is if the same root appears more than once, that root is called repeated or multiple root. It actually has a lot of different names, but those are the two most common. So here's an example of a function that is going to have multiple roots, or zeros. So if I actually set this equal to 0, I'm going to have a root of positive 1 and negative 4. But I have this power up here that's a 2 and a power up here that's a 3. What that tells me is that this positive 1 root, or 0, 1, or root 1, is going to have something that we call multiplicity of 2, depending on its degree. So multiplicity sounds a lot like multiplication or multiple, so that just tells me that I have multiple roots that are going to be 1, and in this case it's 2. On the same side, we have this positive 4, which will result in a negative 4, 0, or root, and that's going to have a multiplicity of 3 because the degree of this part is going to be 3. So if we actually take a look at multiplicity a little bit closer, it actually has two defining characteristics. So multiplicity can be even or odd depending on the degree of the part of the function. So here we have an even multiplicity because of this power here, which is 2. Now when I look at that, I notice that it's going to touch the x-axis and go back up. If I look at another example of even, which is over here, it's going to do the same thing. It's going to touch it and go back up. Same thing over here, touch it, go back up. Now if I look at an odd example, which is the power of 3 right here, I see that it comes up, touches it, and goes through. Same thing down here. Touches it, goes through. Let's look at this part of the function. Comes down, touches it, goes through. Same thing here. Goes up, touches it, goes through. So the rule here is that an even multiplicity will touch the x-axis, and an odd multiplicity will cross the x-axis. Something we've seen before is the turning points of a graph. So that is where a graph goes from increasing to decreasing or decreasing to increasing. Now we've talked about that when we talked about extrema, so our absolute and local max and min points. So anytime a graph has a turning point, that's typically our local max or min points. Also something to know that if a polynomial has a degree n, whatever that n is, it will have at most one less turning point on its graph. So for example, if I have a polynomial function with a degree of 5, it will have at most 4 turning points. So let's end with something called end behavior. And end behavior is something that we're going to talk about at length, but let's start with the basics. So end behavior is for large values of x, so when I plug in numbers that are really, really big, a polynomial function resembles its power function. So let's take a look at an example here. F of x equals 5x cubed minus 2x squared plus 1. So this here is the graph of the original function in black, and that's actually going to resemble the power function, which is just the first part of the function. So that's 5x cubed for large values. Now in this second graph, it doesn't look like it resembles it too much because I've zoomed in. And if I actually zoom out, which is our third graph here, if I zoom out for really big values of x as it approaches positive and negative infinity, I see that it actually starts to look like that function. And as I zoom out more and more, the functions will resemble each other. So they have similar end behavior, which actually helps us figure out important information about the graph without having to use such specific pieces of the function.
That's going to do it for this video. Thanks for watching.